So what's happening in space right now, Thomas? We can take a look at it. Describe to us what we're actually looking at.
Thanks to this great digital image, we can see the upper stage is traveling above Africa, and we are currently finalizing the tilting maneuver in order to reach the separation direction asked by Intelsat. And that is what just happened. Intelsat 17 has been released from the launcher.
So we have separation of Intelsat 17. There she goes. Intelsat 17 heading out on its own journey into space to its final orbital position. Congratulations to Intelsat and to everybody at L'Oréal.
Yeah, this is the beginning of Intelsat 17 journey, and now the satellite has to climb to its final position in space on geostationary orbit, and that's 36,000 kilometers above the Earth.
And of course we still have HYLAS 1 attached to the upper stage, and we have to now continue going through more manoeuvres. What's happening right now?
Well, again, we are positioning, reorientating the upper stage with the Silda in order to separate the Silda on the right direction in order to avoid any collision risk with the just released Intelsat 17 satellite.
And this is, of course, what we call collision avoidance, all very carefully planned and predicted in advance. And we're looking here at the various people in the Jupiter control room in mission control.
You know what I was thinking, Katie, is incredible, because Intelsat 17 was sitting next to us 10 kilometers just 27 minutes ago. And right now, it's like 1,000 kilometers traveling at more than 10 kilometers per second. Isn't that incredible?
It's quite remarkable, and I have to say, what I often find interesting is when you're looking at images on the screen, it always looks like things are happening terribly slowly up there in space, but the reality is it's happening at incredible speeds.
Just to give you an idea, Katie, you know, the fastest man on the world, Usain Bolt, record man on 100 meters can do 10 meters per second. The fastest car, Ferrari, 100 meters per second. Sound barrier, 330 meters per second. A bullet is nearly 1,000 meters per second. Right now, Ariane 5 is traveling more than 10 times faster than a bullet.
10 times faster than a speeding bullet. And what, the fastest man-made object, what would that be?
Well, that was HYLAS 2, was sent a probe, internationally probe, sent towards the sun.
We're now looking, Thomas, I just interrupt you, we're looking at the Silda, which is moving away, separation of the Silda. That was the black structure that we could see there, like a little bit like a fairing, protecting HYLAS 1 and providing the attachment for Intelsat. And for the first time we can now see HYLAS exposed to space. Talk us through this collision avoidance here with the fairing, Thomas.
Yeah. Actually, there is a pyrotechnic device which separates the Silda from its base, and then a set of springs push the upper part away.
So HYLAS is a very important milestone in the history of ESA, because this is the first public-private partnership that we are launching today. And this is the first of several ones which will come in the following years. With that mission, HYLAS, ESA, and the operator Avanti are joining their forces to make a common project, where ESA is providing a brand new technology, and Avanti is using that brand new technology to deliver new services to Europe. So this is a very, very important milestone, because this is the way I would like that ESA is working in the future in the telecommunication field. Speaking of telecommunication, this is 10 years that we have not launched any telecommunication satellite at ESA. The last one was in 2001, Artemis, and today we have the next one. And after that, we shall have one almost every year. So just to say that life is changing in the telecommunications at ESA.
So it just shows that HYLAS 1 really is a trailblazer in more ways than one. It's an interesting setup, isn't it, Thomas?
Yes, actually, it's a perfect example of how ESA can make brand new technology available to a private company so that everybody in Europe can benefit.
It gives me a great pleasure to be in Kourou once again. The Indian Space Research Organization has developed the HYLAS 1 spacecraft at Bangalore. We have done it along with Astrium we are partners together in developing this highly agile and adaptive spacecraft for Europe. This is one of the finest satellites we developed at the ISRO Satellite Center. The satellite is based on a I2K bus. Approximately 2,500 kilograms is the mass of the spacecraft. It works in the KU and KA bands. There are 10 transponders and 2 are in the KU and 8 are in the KA band. This was one of the biggest satellites we made. The testing was very, very elaborate since the spacecraft payload is very complex. We took almost 35 days of thermal vacuum test in Bangalore, and we are fully satisfied the performance will be good. We are really glad that we'll be able to launch this using the Ariane 5. Thank you.
With HYLAS, Astrium is extremely proud to provide Avanti with a top-level telecommunication Ki-band technology. And I would like to thank and congratulate Avanti for their entrepreneurial success. I would like also to extend my thanks to ECA, which has been organizing this very successful PPP. And last but not least, I would like to thank Antrix, the subsidiary of ISRO, for this already successful partnership with Astria.
So there's the upper stage, the upper composite with HYLAS attached, and as we said, we are going through a set of different manoeuvres here, all very, very carefully planned. How does the upper stage orientate itself?
Actually, we have 12 small thrusters spread around the external skin of the launcher, and they use bursts of cold gas coming from the upper stage tanks to provide the thrust, and that allow us to have any yaw, pitch and roll movement of the upper stage. So basically we can twist it in any direction we want in order to reach the required separation direction required by the satellite.
And of course we are effectively injecting the satellites at a tremendous speed into space so that they're then able to carry on their journey. You know, it strikes me, we were talking about speed earlier and you were giving us some comparisons. It strikes me that it's a little bit like throwing a stone. If you were actually able to throw a stone fast enough and you were strong enough, it would effectively not come back down again. It would all but yes. Is that right?
Yes, exactly. We'll come back to you from the other side of the world.
So we now have separation of HYLAS 1. Congratulations to everybody. It's a very big day.
That's the culmination, Katie, of many months and for some years of work, and for some others it's just the beginning of work.
And for many people it is the beginning now because 2 new babies are born, 2 very important satellites.
And what is worth saying is that, you know, this is the result of a big international effort. We have people from all around the world gathering here in Kourou. We have the Indians, the Americans, Europeans, and they all work together to have, you know, such great success tonight.
And here we can see HYLAS moving away at tremendous speed, heading off on its journey. And of course the upper stage is actually going through a whole set of manoeuvres. It hasn't stopped, has it? It's going through what we call a passivation process.
Actually, the upper stage will go through a passivation process to blow down the tanks because we don't want to have any dangerous space debris up there.
And here we go, look, there's that beautiful launch. We were so lucky tonight, this afternoon. We had that fantastic clear sky. We saw it all the way through to separation of the boosters. Sensational. Feel the vibrations coming from the launcher during that launch.
We could feel the vibration from the commentator booth.
Yes, absolutely. It was sensational. And of course everyone's now feeling very happy. Teams have worked extremely hard. Some of those teams have been working here on the base, living in French Guiana for the last few months. Others arrived just the last few days.
And look at this replay, which is from the Toucan, which is the closest observation point of view. It's just amazing.
We can see the 3 engines burning there, but the 2 huge powerful boosters hauling Ariane.
It's quite rare to have such incredible weather with no clouds in French Guiana. I mean, and moreover, you know, it was a day launch.